we have a workshop where we can print easily and quickly 3D shapes and 3D samples. And that's, of course, something which was loop, where you can quickly measure, model, produce by rapid prototyping, measure again, compare with the model, close the loop.
So the starting point was the original 800 head. We needed to make that head in the same process we were going to prototype the new head. So that's where we started. So we started with the original head, printed it and using exactly the same process we were going to use to prototype the new turbine head. And that obviously gave us a benchmark to then test all other heads from. And we were able to then reiterate that as many times as we needed to. We could improve areas very quickly, do the turnarounds in-house, gives us the ability to do these very, very quickly. We also had a very good system where we were able to emulate the original head as a 3D printed part very, very well, and that meant we knew where the improvements were and where the improvements were coming from and what we were doing in all future development work on the turbine head. And the original prototypes were only useful for technical measurements. We couldn't use them for listening parts. To do listening, we have to use the correct materials at all times. That's how we work. So what we did, we were able to print the patterns and send them to a local engineering firm, but we were able to cast the part in aluminium, which was what the new head was always going to be manufactured in. It was the preferred material. So from that, we were able to go from a 3D printed pattern, casting the actual finished part as it would be for acoustic trials.